Deep within one of the world's most remote and rugged landscapes, China is pursuing what could become the most ambitious hydroelectric project ever attempted. Located along the Yarlung-Tsangpo River in Tibet, this future megadam is designed to harness the immense energy created as the river plunges through one of the deepest canyons on Earth. But this project is about far more than generating electricity. Engineers are planning to incorporate advanced intelligent monitoring systems, capable of collecting real-time data on structural stress, seismic activity, temperature, and material performance, combined with next-generation self-compacting concrete and thousands of embedded sensors. The dam is being designed to continuously monitor its own condition in one of the planet's most geologically active regions. The location presents engineering challenges, unlike almost anywhere else on Earth. In parts of the canyon, the river drops more than 2.000 meters in elevation over a relatively short distance, creating extraordinary hydroelectric potential. If completed as planned, the facility could reach an installed capacity of around 60 gigawatts, roughly 3 times greater than the Three Gorges Dam. Delivering that enormous amount of electricity across China would rely on ultra-high voltage direct current, or UHVDC, transmission lines, allowing power to travel thousands of kilometers with minimal energy loss. The project is expected to require an investment estimated at around $167 billion, making it one of the most expensive infrastructure developments ever proposed. Following its official launch in 2025, after decades of geological surveys and feasibility studies, the project represents the next stage in large-scale civil engineering. Rather than relying solely on bigger structures, modern engineers are increasingly combining advanced materials, artificial intelligence, and digital monitoring systems to build infrastructure capable of adapting to some of Earth's most demanding environments. Whether it ultimately fulfills its ambitious goals or not, the Yarlung-Tsangpo project already reflects a new direction in engineering, where intelligence, data, and precision are becoming just as important as concrete and steel. Imagine building a railway that stretches for more than 1.600 kilometers through some of the most unforgiving terrain on Earth. Along much of its route, trains travel not across open ground, but through an almost continuous sequence of tunnels and bridges, carved into towering mountains and suspended above deep river valleys. The Sichuan-Tibet Railway is far more than a transportation corridor. It is one of the most technically demanding railway projects ever attempted. Connecting Sichuan province with the Tibetan Plateau requires engineers to overcome extraordinary changes in elevation, climbing from just a few hundred meters above sea level to well over 4.000 meters to maintain safe operating speeds. While navigating this rugged landscape, the railway passes through numerous mountain ranges, using an extensive network of tunnels and long-span bridges. In many sections, traditional railway construction simply wasn't possible, forcing engineers to develop entirely new solutions for one of the world's most complex geological environments. Construction has presented challenge after challenge. Workers have encountered active fault zones, unstable rock formations, high groundwater pressure, and the constant threat of earthquakes. At high altitudes, thin air, freezing temperatures, and unpredictable weather make every stage of construction significantly more difficult. Some of the most demanding sections, including the Ya'an-Ningqi route, are expected to require well over a decade of continuous engineering work before completion. with an estimated investment of around $47 billion. The Sichuan-Tibet Railway represents far more than a massive infrastructure project. Once completed, it will dramatically improve transportation across one of China's most remote regions, reducing travel times while strengthening economic connections between the Tibetan Plateau and the rest of the country. More importantly, the railway demonstrates how modern engineering is steadily overcoming obstacles that once appeared insurmountable. Every tunnel, bored through solid rock, and every bridge, spanning deep mountain valleys, is another reminder that today's greatest engineering achievements are often built where nature presents its toughest challenges. What if two of China's largest cities could feel as though they were only a few hours apart? That idea became reality with the Beijing-Shanghai high-speed railway, one of the busiest and most advanced high-speed rail corridors in the world, stretching approximately 1.318 kilometers and built at a cost of more than $33 billion. The railway connects two of the country's most important economic regions, transforming the way millions of people travel every year. Operating trains at speeds of up to 350 kilometers per hour requires far more than powerful locomotives. It demands extraordinary precision in engineering to ensure a smooth and stable journey. A large portion of the railway runs on elevated viaducts rather than directly on the ground. This design minimizes sharp curves, reduces ground settlement, and allows trains to maintain high speeds safely across a wide variety of landscapes. Among its most remarkable structures is the Danyang-Kunshan Grand Bridge, which stretches more than 164 kilometers, making it the longest bridge in the world, crossing rivers, lakes, farmland, and urban areas. The bridge allows the railway to follow an almost perfectly level route, reducing vibration and improving long-term reliability for high-speed operations. The railway also showcases China's growing expertise in high-speed rail technology. Modern Fuxing trains are equipped with advanced onboard monitoring systems that continuously analyze operating conditions, track performance, and mechanical components in real time. These intelligent systems help maintain safety while allowing trains to operate at some of the highest commercial speeds anywhere in the world. Since entering service in 2011, the Beijing-Shanghai high-speed railway has carried well over 100 million passengers annually, while reducing travel time between the two cities from around 10 hours to less than 5. More than simply moving people faster, it has reshaped business, tourism, and daily life, demonstrating how modern engineering can make vast distances feel remarkably small. Our final destination is a structure that represents far more than an airport. Beijing Daxing International Airport is a masterpiece of modern engineering, designed to redefine how millions of people move through one of the busiest transportation hubs on Earth. Completed in just 5 years, at a cost of approximately $11.5 billion. The terminal covers more than 700,000 square meters. Beneath a striking star-shaped roof, inspired by flowing geometry, rather than relying on a dense forest of interior columns, the enormous steel roof is supported by a carefully engineered structural system, centered around 8 massive support columns. This open design creates vast uninterrupted spaces, while allowing passengers to move efficiently throughout the terminal. Natural light also plays a central role. In the airport's design, thousands of skylights flood the interior with daylight, reducing the need for artificial lighting, while creating an environment that feels bright, spacious, and surprisingly calm, despite handling tens of millions of passengers each year. Here, architecture is not only about appearance, it is an essential part of the building's performance and energy efficiency. The innovation continues below ground. High-speed rail, intercity trains, metro lines, and airport transportation systems are seamlessly integrated beneath the terminal, allowing travelers to transfer between different modes of transport with remarkable efficiency. Advanced engineering techniques, including vibration isolation and precision structural design, ensure that these underground systems operate without compromising the stability or comfort of the airport above. Looking back at these 8 extraordinary projects, one thing becomes clear: their true significance extends beyond their size, cost, or technological complexity. Together, they demonstrate how engineering has evolved into one of humanity's most powerful tools for overcoming challenges that once seemed impossible. From ancient fortifications and imperial palaces to high-speed railways, megadams, and next-generation transportation hubs, each project reflects a different chapter in the story of innovation. They remind us that progress is driven not only by ambition, but also by knowledge, precision, and decades of perseverance. At the same time, every engineering achievement carries responsibilities, as our ability to reshape landscapes continues to grow. So does the importance of balancing development with environmental protection and respect for the communities affected by these projects. The greatest accomplishments of the future will not be measured solely by their scale, but by how wisely they are built. Perhaps that is the most important lesson these engineering marvels have to offer. They are not simply monuments to technology. They are milestones in humanity's ongoing effort to solve increasingly complex problems. Thank you for joining us on this journey through some of China's most remarkable engineering achievements. If you enjoyed this documentary and want to explore more extraordinary megaprojects, lost civilizations, and groundbreaking innovations from around the world, be sure to subscribe to Atrox. We'll see you in the next exploration.